students, good day and welcome back to my channel. Please, if you are new here, consider subscribing. Okay, very quickly, let us get into what we have today. We need to understand the concept. In this lesson, we are going to be understanding the concept of hybridization in carbon precisely. So hybridization in carbon, like I have here, says this is defined as the mixing of the 2s orbital and 2p orbital of carbon to form a more stable orbital which is more modified for bonding. Very, very important. So I want you to understand that carbon atom has 3 orbitals: the 1s orbital, the 2s orbital, and the 2p orbital. But this hybridization simply has to do with the mixing of the 2s orbital and the 2p orbital of carbon. Very, very important. And whenever these 2 orbitals mixes together, it forms a more stable orbital. It does not just end there, and again a more modified orbital for bonding. So it therefore means that 2s orbital and 2p orbital, when they are independent in themselves, they will not be more stable and they will not be more available or be more exposed for bonding. So when they are combined to form they will form a more stable orbital. First, I want you to understand that carbon atom has atomic number 6, and if we write the electronic configuration of this carbon atom, we are going to have 1s2, 2x2, and 2p2, sorry, not 2p6, and 2p2. So this is nothing but the electronic configuration of carbon. And I want you to understand that this now, this is the electronic configuration of carbon, and again there is a state of carbon that I want you to understand, which is ground state, which is ground state of carbon. So in the ground state of carbon, it will mean that this orbital will have 2 electrons, and this orbital again will still have 2 electrons. Alright, so in the ground state of carbon, nothing much actually happened. What actually happened in the ground state of carbon is that 1 electron from the 2s orbital move into the 2p orbital. So let me quickly show it. So this is the carbon, and this orbital, this 1s orbital is this, having 2 electrons spinning in opposite direction, and this 2s orbital is this. It will be slightly higher in energy level than the 1s, and again it will have 2 electrons spinning in opposite direction. Very important. Then finally, this 2p orbital will be higher in energy level than the 2x, and it will have 3 electron blocks, each electron block containing, the first 2 electron blocks containing one electron each, and this one now is empty. So pay very close attention. From here down to here is actually a 2p orbital. Alright, so precisely I want you to understand that this particular orbital is called the 2px, and this is called the 2py, and this is called the 2pz. Okay, so this is the electronic configuration, or this is the orbital diagram. Alright, this is the representation of this electron block in the ground state of carbon. So in the ground state of carbon, this 1s has 2 electrons, this 2s has 2 electrons, and this 2p has 2 electrons, and precisely in the 2pz it has no electrons. So particularly, or maybe precisely, the 2pz, the 2p generally is unstable. Alright, so now that will take us to the excited state. If this 2p, on the course of trying to be stable, gains 1 electron in the 2pz, that form, or maybe that new state it will acquire, is what we call the excited state. So very quickly, let us see another state of carbon, which is called the excited state of carbon. Very important. So in the excited state of carbon, which has atomic number 6, let me draw the 1s orbital. So the 1s orbital is here, still untouched. Now the 2x and the 2p orbital, both of them will now combine to give us a single orbital like this that has 4 electron blocks. Alright, note that these electron blocks, they are supposed to be equal. Okay, so each of them will contain one electrons. So, but precisely, I want you to understand that this particular electron block is the 2x. So we can say that from here to here is the 2x. Alright, and from here, let me just make it more nice so that you see what I'm trying to communicate. Okay, so from here to here is a 2x, and from here down to this very place is a 2p. Okay, so this is what I'm trying to say. So now this, at this point now, this is the ground state of carbon where the 2x and the 2p are still separated. But at this point where the 2x and the 2p has been combined by reason of 2x giving one electron to 2p, this is called the excited state of carbon. And something very important you need to know is that carbon does not exist in its ground state. Although ground state is expected to be the normal state of carbon, but carbon does not exist in the ground state, but it exists in the excited state. So the excited state of carbon has 4 unpaired electrons, but in the ground state of carbon, it has 2 unpaired electrons. Now, by reason of, had it been carbon exist in the ground state, carbon would have been divalent in nature. But because carbon does not exist in this ground state, but it do exist in the excited state, that was why carbon is tetravalent. And it therefore means that whenever carbon is drawn in any organic compound, it must be surrounded with 4 bonds. Alright, so these 4 bonds of carbon explains, or maybe this excited state of carbon explains why carbon must be surrounded with 4 bonds whenever it is drawn in any organic compound. Very important. So a quick recap of what I've just said. I just said that hybridization is nothing but the mixing of the 2x orbital and the 2p orbital to form a more stable orbital that is more modified for bonding. So if you watch carefully in the excited state, in this excited state now, this 2x orbital and all of these 2p orbital, they can mix in 3 different ways. And these 3 different ways by which they can mix brings about the 3 different kinds of hybridization we have. The first is called sp3 hybridization. Then the second one is called the sp2 hybridization. And the third one is called the sp hybridization. Okay, very quickly, hybridization generally has to do with the mixing of the 2x and the 2p orbitals. Very important. Now, sp3 hybridization has to do with the mixing of the 2x and the 2p orbital such that 1 electron from 2x and 3 electrons from 2p will be involved. Very important. Now, the sp2 hybridization also has to do with the mixing of the 2x and the 2p orbitals of carbon such that 1 electron again will be involved from 2x and 2 electrons will now be involved from 2p. Then finally, the sp hybridization also has to do with the mixing of the electrons or the mixing of the orbitals of carbon such that 1 electron each will be involved from 2x and 2p. So it therefore means that for sp3 hybridization, we can say that the ratio of the electrons is nothing but 1:3. And for sp2, we can say that the ratio of electrons in the 2 orbitals is 1:2. And finally, sp, the ratio of the electrons is 1:1. Okay, so another important thing I want you to also understand in this concept is that sp3 hybridizations is usually found in alkanes. Alright, sp3 hybridization is usually found in alkanes. And sp2 hybridization is usually found in alkenes. Then finally, sp hybridization is usually found in alkynes. Alright, so these alkenes, alkenes, and alkynes, these are the 3 hydrocarbons we know. Alright, I think I've already made I've made a video under the concept of hydrocarbons, so you can quickly go and check the video I made under hydrocarbons, I meant to say. So this is it. Alright, so you can carefully take a screenshot of the board and make a note. Alright, so thank you for watching my video to the end. I appreciate and thank you so much.